Look, I solve multiple Leetcode problems every day. This is find the score of all prefixes of an array. Okay? Okay. So we define the conversion array, convert of an array. We define the conversion array, convert of an array as follows. Okay. Always a good idea to start the problem by just stating the equations. Either think about them, consider them, or write them down is probably a better approach. So we know that the conversion array value, conver, at index I equals the array at I plus the max, so the maximum value of the array at every index that's less than the current index I, less than or equal to. Okay, so in human language, right, the conversion value at index I is the array at index I plus the maximum value before I plus 1. So if we have an array like 2, 3, 7, 5, 1, right? At index 0, right? For example, let's just go ahead and get right into the example. Let's go ahead and get right into the example. If we had this array equals 2, 3, 7, 5, 10, 2, 3, 7, 5, 10. If this was the case, right, and we wanted to figure out what the conversion array is, well, let's think about each I value. So I could be 0 here, I is 1 here, 2, 3, 4, right? Because I just represents the index. And then if we wanted to figure out what our conversion array was, well, it is what? Well, conversion at I equals 0. So conversion at I equals 0 equals the array at I equals 0 plus the maximum of the array. And I'm just directly substituting I with I equals 0 here from 0 all the way to I equals 0, right? So array at I equals 0, that's just 2 plus, and then the maximum of the array at 0 to 0, because this is the array from 0 to 0. So that's only one element, which is 2. So it's 2 plus 2 equals 4. Okay. What about I equals 1? Okay, so conversion at I equals 1 equals the array at I equals 1 plus the maximum of the array from 0 to I equals 2. So the array at I equals 1, that's just 3, right? Maximum of the array from array 0 to I equals 2. Right, so that's the maximum of the array 0 to, why'd I put 2 here? I equals 1, sorry. I equals 1. So what is the array 0 to 1? Right, so this is a subscript notation. So this is the first two elements of the array, right? I is 1 here, so 2, 3. So that's the maximum of 2, 3, right, which equals 3. So then we have 3 plus 3, which is 6. Okay, for this one, so we'll keep going, right? For this one, the maximum would be 7, right? The maximum of these three things is 7, plus the value itself is 7, so that'd be 14. All right, here, the value is 5, but the maximum of everything to the left, right? Since this array 0 to I means that we're going to take I and then everything to the left, the maximum of that would be 5 is the array value and 7 is the maximum, so 5 plus 7 is 12. And then for this last value, we have 10. 10 is the value of the array plus the maximum, everything to the left is 10, so 10 plus 10 is 20. So this would be our conversion array, right, after we run through this whole process, okay? We also, so that's this conversion array, we've just found it for this example. We also define the score of an array as the sum of the values of the conversion array of array. Given a 0 index, so the score array is just the sum of everything to the left, right? So the first one is 4. Then the next one is 4 plus 6, which is 10. Then the next one is 14 plus 6 plus 4, which is 24. And the next one is 14 plus 6 plus 4 plus 12, which is 36, right? And then the next one is 4 plus 6 plus 14 plus 12 plus 20, which is 56, right? Okay, so the interesting thing, and you'll see that's the output here, because we return given a zero index array nums, right? So I called it array here because they called it array here, but right. So this array, given this array of length n, return the array answer of length n, where answer I is the score of the prefix num 0 to I. So that's the score array here. Okay. So the interesting thing about this problem, right, which isn't always a luxury that you're given, is that this problem specifies the data structure or the algorithm, whatever, that you're going to use in the solution, right? It says find the score of all prefixes. So that should be a pretty clear indication, right, that we're going to be using, you guessed it, prefixes. So in order to solve this problem, you need to understand the notion of prefix sums, okay? Because to solve this problem inefficiently, right, what we would do is for each element, we'd find this information here. Right, for each element, we'd have to solve for this information here. So that's going to take n squared time, right? Because I have to look at each element, and then I need to find the maximum element, including that element and everything to the left, right? When I look at this element, I have to look at this element and everything to the left. And then when I look at this element, I look at this element and everything to the left. And then when I look at this element, I have to look at this element and everything to the left to figure out what the maximum is, right? Because every time I find this conversion array, I have to look at the element, and then I need to find the maximum thing to the left. So I have to look at the element, then I have to look at everything to the left to determine what the maximum value is. And then when I look at the next thing, I look at the element and look at everything to the left to determine what is the maximum value, right? So that's going to take n squared time, because for each element, I have to look at everything to the left, so that's proportional to n. So for each n elements, I need to look at n things to find the max, so that's n squared time. Now, maybe that would be sufficient, but since this num's length is 10 to the 5, that means n, num's length, is 10 to the 5. N squared is going to be 10 to the 5 times 10 to the 5. 10 to the 10, you're going to get a time limit exceeded error. Right? So we need to think of a clever trick to not have to recalculate this information, right? Because setting array I, conversion I equals array I, this is constant, right? This is a constant operation here, right? This part is constant, because I'm just grabbing an element from the array. But right now, if we want to calculate the max from everything to the left, this is an O of n operation. So we need to find a way to take this component of finding conversion and convert it into an O of 1 operation, okay? And the way that you do that is this notion of prefixes, right? So the notion of a prefix is keep track of what you've already solved and add to it, okay? So you're going to keep track of what you've already solved and add to it. That way you don't have to resolve everything, right? Because so let's look at this problem, right? In a different way. So when our array is equal to 2, 3, 7, 5, 10. Now let's imagine we've already solved some elements of conversion from left to right, right? So we said this is 4, and this is 6, and this is 14, okay? When we're solving for this element, right, we know we're going to add in 5, okay? And what we're also going to have to add in is the max, right? We're going to have to add in the maximum of the array, right? In order to calculate conversion at 0, 1, 2, 3, conversion at 3, we're going to need the array at 3, and then we're going to need the maximum from the array at 0 to 3, including 3, right? So the brute force way would be, okay, just look at this whole array and find what the maximum is. But something you'll notice is, what have we already done here? Well, since we've already done index 2, that means we've already solved what? We've already solved the following, right? We've already solved this, right? We've already solved the maximum from array 0 to 2, right? We've already solved that information. That information is here. It's 14, right? So we've already done the work to find the maximum of the array as 0 to 2, right? So we can rethink about what this means, right? The maximum of 0 to 3. Now I'm doing a very mathematical way of approaching this so you can see kind of how this is derived, but then we'll just talk about a more intuitive kind of more obvious way you'll do this in your code, and maybe it'll make more sense. So it really depends on what kind of mind you have. Maybe you're more mathematically oriented and this is what you want to see. You want to see the actual math kind of that makes this work, or you're more just like kinesthetic and you just want to see, you know, what does the code look like? How does this operate? Give me an example. So we'll do both. So bear with me. Okay, so the max of 0 to 3 is what? It's the same thing as the max of the array from 0 to 2, or the array, you call it the, so you could take the newest element or the max of what comes before. So these two things are logically equivalent, right? The max of the array from 0 to 3 is just the max of the current element, array 3, the max of that with the max of the array from 0 to 2, right? But what you'll notice is like, well, we've already done the work to find this information here, right? So one thing you could say is, well, the max of array at 0 to 2 equals, if I just reorient this function so I move this over, right, equals conversion at 2 minus array at 2, right? Okay. So basically I can replace this information into here. So that means that the max at array at 0 to 3 equals the max of array 3, or conversion of 2 minus array at 2. So what I'm basically saying is the max, so then, right, I can just look at the previous thing that I've solved to find what the previous max was, and I can say, well, is the new value I have greater than the previous thing, which was the max? Right, that's all we really need to do. All we really need to do is keep track of what the maximum value is as we go. We don't need to recalculate everything because in the previous conversion index, we've already solved the max for those values. So at our new index, we can just bring in one new variable to determine if that's the new max. We don't need to keep recalculating the max for the whole system. Let's just keep track of the max as we go. And if the new thing is greater than the previous thing we thought was the max, then the new thing will be the max, right? So you could do it like this. That's kind of the mathematical way of looking at it. Or when you solve this problem, what you'll do instead is you'll just include a variable that represents the max, okay? So we'll just delete all this because it's all junk. Everything I do is junk, right? So when we solve this again for conversion, what we'll do is we'll say, well, let's also keep track of the max value, all right? So the conversion first is, well, our array element is 2, and the only value we have so far is 0. So maybe we'll start the max value as 0. Or, okay, everything's greater than 1, so yeah, that's fine. So our initial value for max is 0, and we'll say, okay, our new max, our previous max up to this point is 0, so our new max will be 2, right? And then we'll add that to our array element to get 4. Then when we look at 3, we'll say, okay, is 3 greater than what before was the max to our left? Yes, so our new max is 3. And then we add that to 3 to get 6. Then we look at 7. We say, is 7 greater than the previous thing we thought was the max? Yes. And then we add that to our array element, which is 7, to get 14. Finally, something different. We look at 5 and we say, is 5 greater than the previous thing we thought was the max? Because the previous thing that we thought was the max is the max from 0 up until the previous thing. So this 7 encapsulates the max of everything to the left. So when we look at 5, all we have to do is look at the max of everything to the left and 5, and we say, no, 7 is greater. So the current element we're looking at doesn't have the max. The max is somewhere to the left of the current element. So we just say, no, the max is still 7. We add that to 5, and we get 12. And then we look at, this is supposed to be a 10. And we say, okay, the max of everything to the left is 7. Then we look at 10. We say, is 10 greater than the max of everything to the left? Okay, so then the new max is 10. And then we add that to our solution, and we get 20. Right? So that's a fast way now in constant time to calculate this conversion array, right? Because we don't need to keep recalculating the max. Instead, we use this prefix idea to just say, what's the max of this element, So we have like a running max that we use to keep track of what the maximum is, okay? So we'll do that quickly. Oh, don't look. I already solved this problem, and I didn't realize I didn't delete it. Okay, so we'll start our max value as 0, right? And then what we'll do is we'll just convert nums directly into conversion, okay? So I'll look at each index and num in enumerate nums. And then what we'll say is, well, is m is going to be the max of whatever we thought the max was before, or num? And then we'll just set the index to the num itself, right? Because the num itself is the value at that index, so that's array at I, plus m. Right, and then if we print nums here, just for the sake of testing, nums is now going to be the conversion array, because I'm just doing it in place. That way we can do a constant space algorithm. Right, so 4, 16, 14, 12, 20. Of course, this isn't the answer, because the answer is the score array, which is, the value, the prefix from 0 to I at each I. So is this the same as what we were getting over here, right? 4, 6, 14, 12, 20. Is that right? 4, 6, 14, 12, 20. Voila, we have the conversion array now. Okay, so we've used the prefix idea in summary. We use the prefix idea to convert something that would take n time into constant time by just keeping track of what the maximum value is as we go along. Because this maximum value will always give you the maximum of everything to the left. So then when you include one new thing, you just calculate in constant time the m value, which encapsulates everything to the left, and this one new additional value, the maximum of those is the maximum at this point, right? Okay, so now what we need to do is the score of the array is the sum of the values of the conversion array, right? So given a 0 index integer array nums of length n, return the array answer of length n, where answer I is the score of the prefix nums 0 to I. Okay, so the answer is basically just a running sum, right? If this is our convert, I'm going to delete this here. We're going to have this answer, right? An answer is just the sum of the array of conversion from 0 to I, right? So from 0 to 0 is just 4. And then when it's 1, we have to sum these together to get 10. And then when it's 14, we have to sum these together, right, to get 24, so on and so forth. Now, we're kind of going to do the same thing again, right? Because when we convert answer, we can look at everything to the left every time, right? But that's going to take n time for each thing. So now we're going to blow up 10 squared again. But if we use this prefix idea again, we can keep track of it while we're running through, keep track of what the value is, and then just add to it, right? Because if you think about this, right, what this really equals is the sum of conversion at 0 to I minus 1 plus conversion at I. So you can split it up, right? So if we solve and keep track of what this value is, then we can just add in this new value to then get our new answer value here. Okay? So all that really means is instead of populating the whole thing, all I need to do is add the current value to the previous value, right? I find out it's 4, then I add 6 to get 10. The previous value is 10, so I don't need to sum up the whole thing because I have it right here as 10. So then I just add 14 to get 24. And then previous value is 24, so then I just add the current conversion value of 12 to get 36. And then I add 20 to get 56, right? So now it's a constant time algorithm because when I run through, I just keep track. And what we can actually do is do this in real time, right? So we can say nums at index equals num plus m plus nums of index minus 1, because nums of index minus 1 will get populated with the score array. So now this will be the score array if we do it like this. Now this might be a little bit complicated, so you might want to review this a little bit, but the idea is that we're doing it all in place, right? We're in place modifying nums, so we don't have to use any additional space, right? Now, you don't want this to be negative, so you just say int index minus 1 greater than or equal to 0, just to take care of that first example. And then when we do that, we just return nums. We run this. All right, there you go. And then we submit it, and we cry because I did something wrong. Okay, so what is the runtime and space complexity of this problem? Let's say n is the length of nums. Okay, so our brute force solution was n squared. But if you look at this, we look at each number. So we look at all O of n numbers. We find the max as a constant operation, and then we calculate the score. This portion is the conversion value for the current index. This portion is the conversion. This portion is the prefix value for the score value for the previous index. So then we just calculate the current score value for the current index by doing that. So we take the conversion value, then we add in the score value from the previous index, and that gives us the score value for the current index. But these are all constant operations, right? Adding this is constant. Taking this out is constant. Finding out if it's greater than or equal to 0 is constant. So for every n thing, we do a constant thing and another constant thing. So for every n thing, we do 2 constant things. That's 2 constant times n. That's big O of n. And at the end, we just return the array. It's constant. So this is big O of n time. Now, in terms of space, well, we create this variable. We update it accordingly. We look at each element, but we only need to create space for this one variable and then create 2 additional spaces every time we look at the variable, but at most 2, right? So we create like 3 variables, right? We create a constant number of variables. So if there was 1 billion nums or 2 nums or 400 nums, whatever it is, we're just going to be using a constant space. So this is O of 1 space. Now, someone might be mad because we're modifying the nums that we're given, so perhaps that's not a good idea. And maybe you would use n space to get the answer, but you use constant extra space, right? So sometimes you hear that kind of language in these problems, and that's what it essentially means, right? Because in order to do this problem without modifying nums, we have to create an n space array to hold the answer, right? But we use 0 constant extra space, right? Because we'd have to create an array of size n, but then extra after that, we don't use anymore except for constant. So this is constant extra if you don't want to modify nums. It's constant in general if you are willing to modify nums. So O of n time, O of 1 space, it can't get much faster than that. Well, it can, but not in this problem, because for this problem, you have to look at every value to calculate it, so it can't be faster than O of n. All right. Peace out, everybody. Boom.